All right, welcome to The Explainer. Today we are going to unravel the mechanical magic behind some of the most common fabrics we see every single day. We're talking about the Dobby Loom, the machine that weaves the code right into your clothes.
Have you ever looked really close at a piece of fabric, like a kitchen towel or a shirt, and noticed those small geometric patterns that are actually part of the weave itself? Well, the secret to how that's done lies in this really clever device that sits right on top of a loom, and it acts like a kind of mechanical programmer. So, the official term is Dobby shedding. And really, it's just a method for making these small, repeating patterns by telling specific threads exactly when to lift up and when to stay down. But to really appreciate how brilliant this is, we first have to understand the problem it was trying to solve. See, in the world of weaving, making patterns has always been this tricky balancing act between simplicity and complexity, between speed and detail. You basically had two extremes. On one side, you had tappet looms, super simple, super fast, and cheap to run. Great for basic fabrics, but they couldn't really do much in the way of patterns. Then on the other end of the spectrum, you had the jacquard loom. Now this thing was an absolute marvel. It could weave incredibly detailed pictures, but it was hugely complex, slower, and really expensive. Just total overkill for your average everyday fabrics.
So weavers were kind of stuck in the middle. They needed something that could create those nice, small, detailed patterns efficiently without having to fire up a massive, complex jacquard loom. There was this huge technological gap just waiting to be filled. And that's where the Dobby comes in. It was the ingenious solution that perfectly filled that gap.
This quote really just says it all, doesn't it? The Dobby wasn't trying to be the most complicated machine out there, it was trying to be the smartest. It found that perfect, just right spot. More capable than a simple tappet loom, but way less complex than a full-on jacquard.
So how did it hit that sweet spot? Well, by controlling between 6 and 48 shafts, or sets of threads. Now, that might not sound like a ton, but it was the absolute perfect range. Powerful enough to create a huge variety of interesting patterns, but simple enough to keep the machine running fast and affordably.
Okay, so how does this mechanical marvel actually read a pattern and translate it into a piece of cloth? This is where things get really, really clever.
Now, don't worry about trying to decipher this entire diagram. What you're looking at is basically the Dobby's mechanical brain. This isn't digital, it's this beautiful physical system of levers and hooks and knives, all dancing together in perfect harmony to run a program that was written in wood and metal.
So here's how that dance works, broken down into 4 steps that just repeat over and over. First, the pattern is read from a rotating barrel with pegs on it. Think of that as the software. Second, if a peg is there, it pushes a lever and selects a hook. Third, a moving part called a knife grabs that selected hook and lifts it up. And finally, that lifting motion is transferred through more levers to raise the correct threads. Peg, select, lift, weave. It's that simple rhythm that builds the entire design.
And this is the software itself. These are the wooden strips, they're called lags, and they're all chained together. Each one of these lags represents a single row in the pattern. And those little pegs, that's the code.
The logic is brilliantly simple. It's a binary system. A peg means lift the thread up. No peg means leave the thread down. It's a 1 or a 0. This physical pattern of pegs gets translated directly into the structure of the fabric. It is, quite literally, coding with wood.
And just like any good piece of technology, the Dobby's programming method got an upgrade. Those wooden logs worked, for sure, but they were bulky, and the pegs could wear down or break. So the next logical step was to move to a system of punched paper cards, way lighter and a whole lot more durable.
And this shift was a complete game changer. With paper, you didn't have pegs that could fall out, which meant fewer mistakes in the final cloth. Plus, and this was huge, they were so much easier to store. Instead of these big, bulky wooden chains, a factory could keep a massive library of thousands of patterns in a tiny fraction of the space.
So you see, this was way more than just a clever machine. The Dobby had a huge, lasting impact, not just on the textile industry, but, believe it or not, on the history of technology itself. I mean, its versatility made it an absolute workhorse. It could do everything from fancy twills and satines to the intricate borders you see on towels and tablecloths. And because you could swap out the pattern cards so easily, factories could switch between different designs incredibly fast. It made them so much more agile and efficient.
And this, right here, this is the biggest takeaway. The whole idea of using a stored, readable program, first pegs, then punch cards, to control a machine, well, that idea didn't stop with weaving. It became a fundamental principle of automation, and yes, early computing.
Those pegged, lags, and punch cards are the direct ancestors of the punch cards that program the first computers. So yeah, the code that's woven into your clothes helped pave the way for the code running on your screen right now.
It really makes you wonder, doesn't it? What are the Dobby looms of our time? You know those unsung inventions? The perfectly balanced solutions sitting quietly between the too simple and the overly complex that just get the job done. Something to think about. Thanks for watching.